Good morning, good afternoon, or good evening, depending on where you are in the world, and welcome to today's DevOps.com program, brought to you by Techstrong and Broadcom Software. My name is Cody J. Brown. I'm the host of Techstrong Learning, and we have an exciting program ahead. First, I do need to cover just a couple of housekeeping notes. Today's session is being recorded, so if you miss any of our discussion, maybe you'd like to rewatch or share with a friend. The on-demand recording will be made available shortly after we conclude our live session today. If you have any questions, and we really hope that you do, we want you to send those in to us using the Q&A tab. You can find that Q&A tab on the right side of your screen, where you'll also find a few more options. The next one being the chat tab, and that's where we want you to get to know your fellow audience members. Let us know your thoughts throughout today's program, or maybe just from where you are joining us. We do also have a plethora of handouts available for you under that Handouts tab, so feel free to jump over there and grab all of those. And of course, before we close out, we are giving away 4 $25 Amazon gift cards, so be sure to stick around. So the topic of our discussion today is 2022 Accelerate the State of DevOps. What's new and what's next? I'm joined today by Shamim Ahmed, DevOps CTO and evangelist at Broadcom Software, and Dustin Smith, Staff User Experience Researcher at Google. So Dustin and Shamim, thank you both so much for joining me. Dustin, do you want to go ahead and get this kicked off?
Yeah, thank you, Cody. Let's jump right in. Okay, so thanks everyone for attending today. I'm going to walk you through the 2022 Accelerate State of DevOps report and give you an overview of this research program. We've been doing it for the last 8 years, and we look at the various factors that impact a team's ability to deliver software quickly, with stability, and with reliability, all while driving value to the business. And that's a really crucial part of this. We're not saying move fast, break things, and no profit. We're talking about moving fast, maybe occasionally break some things, but learn from it and then profit. I'm going to walk you through this year's results. It's the largest and longest running research program of its kind. We try to be as academically rigorous as possible. It's staffed with a team of researchers that really try to do this in such a way that we're able to draw conclusions that are more generalizable than typical. So let's jump in. But first, I'm going to just give you an overview of kind of those high-level findings that we saw this year. The first and probably the distinct thing about this year's report is that we try to do a deep dive into supply chain security. And last year we've looked at security in 2019, 2018, we've looked at security before, but this year we tried to do a bit of a deeper dive. We looked at the various stages across the software supply chain and looked at to what degree are people actually embedding security checks or practices throughout that life cycle. To what degree has adoption been on the rise or not in terms of those principles. In 2021, what we found is that there are certainly some shifting left practices that are on the up and up. But in 2022, what we found is that there is actually quite good adoption for supply chain security practices. They're just not embedded across the entire supply chain just yet. And I'll show you kind of a breakdown of all of those practices later in this presentation. Interestingly, the most important factor, though, when looking at supply chain security practices was for teams that had high trust, low blame cultures. Those teams tended to have more practices implemented and also saw more value driven to their business as a result, which kind of makes sense, right? We're talking about a really sensitive topic here, something that focuses a lot on vulnerabilities and things going wrong and trying to avoid that. So you need to have that culture in place so that if something does happen, do we learn from it or do we look for who to point the finger at? Teams that don't look for who to point the finger at tend to do a lot better here. We also found that they're 1.4 times more likely to have less burnout than teams that do not have security practices. And finally, teams with high levels of security practices are 1.6 times more likely to have high levels of organizational performance. So again, back to that point at the beginning of the presentation, right? It's not just about implementing these practices. It's looking at when teams implement these practices, are they also successful in terms of business capability, right? They need to, for us to recommend these capabilities, we're looking at both. Number two, we looked at several drivers of organizational performance, and I've harped on this a little bit already. I tend to do that in all my talks. Organizational and team culture is really crucial for performing well. So high trust, low blame cultures tend to have higher organizational performance. That's true across the board for all of our respondents. And it's consistent across all of our years of research. Culture really matters. It's kind of a foundational component of DORA's research program, as it doesn't just look at the technical capabilities. It also looks at how do we work together? Do we blame each other? Or are we always looking to improve and learning from each other? The latter being the more promising approach, if you will. Reliability is also a key factor that we found this year. What's really interesting about reliability is that it seems to be a component that really needs to be in place in order to experiment and do this rapid iteration and fast deployment. With reliability in place, teams can be really successful. High software delivery performance leads to high organizational performance. Without reliability, it all falls apart, right? You don't just keep delivering new updates with low reliability. That really needs to be in place. And finally, we see that cloud drives organizational performance as well. There's an increase in adoption across the board, whether that be you just look at whether or not they've adopted a public cloud provider, or have they adopted the actual capabilities of cloud, which is really where DORA puts its foot down and says that's really what matters. We'll dig into that a little bit more. And then finally, context matter. This year, we did a lot more advanced statistical techniques to see what combinations of capabilities together really make a difference. And so one of the most important findings we found was that high software delivery performance is really only beneficial to organizational performance when operational performance is also high. That's that reliability component in place. So we need to make sure that reliability is in place, that we're doing reliability focused practices, and then we can speed up, right? And then interesting about the supply chain security deep dive was that we found that continuous integration being firmly established was also key to teams being successful when they're embedding all of their security practices. And then finally, we found that different combinations of technical capabilities can really compound on one another and show greater returns than them in their individual parts. So it's not an additive effect, it's multiplicative, right? If you combine continuous delivery with loosely coupled architecture, version control, and continuous integration, all of those work together to see greater benefits than each of them, than the sum of their parts, if you will. And then I think one thing that is really important to focus on when you digest this information is that it's not just about moving faster or optimizing reliability or maintaining stability, right? The mindset here, the teams that are most successful are those that use this as a mechanism for continuous improvement, right? They're looking within, they're trying to understand how can I provide the most value to either my customer, my dependencies, or my own team or the business, right? And they're thinking about how can we iterate on that? How can we get better and better? And that's really why we push on move faster, right? Or be more reliable, so that teams can experiment and learn from one another and get better. Teams that recognize that embrace a philosophy of continuous improvement are the most successful respondents that we see. Okay, so every year we look at comparisons across respondents to try and understand where's the industry at in terms of their ability to deliver software. You may recognize the 4 keys, or if you don't, that's okay. We often refer to these 4 metrics as the 4 keys in DORA. We've got lead time for change and deployment frequency. We call those our speed metrics or our throughput metrics, right? And then you've got time to recover and change failure rate. And we call those our stability metrics. We've used these for a long time. And we found that teams that do well at all 4 of these metrics are the most successful. And typically what we do is a cluster analysis, and we'll look at, for our respondents, how many people fall into which category of performance. And these categories are purely defined by the cluster analysis. So we'll cluster the data and we'll see, well, how does it land? Are there low performers? Are there medium performers? Are there high performers? And what was interesting this year is that we found that a 3 cluster solution using the 4 keys was probably the best solution. We had low performers, medium, and high. And historically, we've had an elite performance category. So if you look at the years, in 2018, we saw our first glimpse of the elite performer, which was a subset of the high performer at that time. And in 2019, the elite performers grew significantly. In 2021, they grew even more. But what's really interesting about 2022 is we didn't really see a distinct 4th performance cluster. And so the quick snap judgment here would reasonably be, well, what happened to those elite performers? Did we lose them? And a spoiler is that no, we did not. If you look at the high performers from this year, you'll see that they are actually very similar to elite performers of the past, right? And so that this graphic here is actually quite misleading. It might make you think, oh, well, the industry is slowing down, and that's not the case. Across the board for all of our respondents, the industry has actually increased in speed. It's just that we've only found 3 distinct groups from one another. We can't find a 4th group that is distinctly elite compared to the others. So we only have low, medium, high. And given the emphasis on reliability that we found this year for how important it is, we thought, well, let's add reliability to the equation, right? Let's treat it as a true 5th key. And so we did an additional cluster analysis. We wanted to see, well, how does reliability change the way that these groups are defined distinctly? And we found 4 different groups now. And so for this table, there's a lot going on. I'll guide you through it very briefly. So for each row that you see here, you've got a different performance group. You've got your starting, your flowing, your slowing, and your retiring clusters. On the top, each column represents a different metric that was used for the cluster analysis. So you've got your stability metrics. I just introduced you to those. You've got time to restore, change failure rate. You've got operational performance, which we use reliability for that metric. And then throughput, we use lead time for change and deployment frequency. What's interesting about these groups is that reliability does matter. We have 3 groups that are able to meet their reliability standards, meet expectations for their reliability, and then 1 group that is only able to do it sometimes. What's interesting about these 4 groups is that they're not necessarily value judgments on individuals that took this survey. And so we've got the starting cluster, which doesn't seem to do poorly or well across the board. And so this might be a group within our sample that is just kind of starting their service for the first time or starting their team for the first time, and they're really trying to figure out how to run. The flowing cluster is probably the most representative of elite performers of the past, right? They're very fast, they deploy very often, they have very short lead times, and they also maintain their reliability standards. So this group sees the best benefits in terms of organizational performance and also burnout, right? They're the least likely to burn out as a result of their behavior. The slowing cluster really maintains the reliability, but does not deploy that often, but is quite quick to recover. And then we have finally the retiring cluster, which really doesn't deploy that often, takes a long time to get a change out, slow to recover. What's interesting about this group is that they have pretty good organizational performance, but the cost is they have really high burnout. So they're not deploying that often. And as a result, their team is not feeling that great about it. So far, I've just talked about descriptively, like what's the makeup of the people that took this survey. And really, that's not that helpful because it just describes the different individuals. So what helps make those different people more or less successful? So that's what this section's all about here. So one industry trend that we found this year is that cloud usage has increased. We've found that since 2018. It just continues to increase year over year. And we found that for public and hybrid and multi-cloud, private cloud, all have increased. The only thing that has decreased is the no cloud category. They're not using a cloud currently. But year over year, I show this slide and then I follow with this disclaimer. Is it's really not about adopting a cloud provider or getting a private cloud set up or having hybrid cloud. It's about what you do with that technology. Right. And so that's why we emphasize the National Institute of Standards and Technology's 5 characteristics of cloud, because we can use that old gym analogy that we've used at DORA for several years now, right? You can buy a gym membership, but you've got to go to the gym. You've got to use the equipment to actually realize the benefits of it. The same thing is true with cloud. You don't just set up a billing account and then reap the benefits of it, right? That only benefits the provider, not you. And so you really need to dig into what can I actually get out of this system, right? And those 5 that are identified by the National Institute of Standards and Technology are broad network access, rapid elasticity, on-demand self-service, measured surface, and resource pooling. And this year, we saw an increase in all of those capabilities, which is a great direction that the industry is heading. Again, reliability is really important. And we found that without reliability, delivery performance doesn't predict organizational performance. It needs to be in place. But once it is, delivery performance really helps organizations succeed. And then we also found that dependable teams make dependable services. And it's back to that team culture factor. It's really the crux of so many of these capabilities. When teams are reliable amongst themselves, they create reliable services. And then finally, and pretty interesting, I'm about to show you a graph about this, is that investment in SRE yields improvements to reliability, which shouldn't be that surprising, right? It's site reliability engineering should improve reliability. But what we found is that you really need to go all in on that philosophy. So if you look at the graph on the right here, I've got normalized scores for you. So for some, that might not be your typical way to look at a graph, but in normalization, 0 is average, right? That's the average for the sample. And what you find is that average adoption of SRE practices doesn't move the needle, really. It moves the needle just about as much as no adoption of SRE practices. So if you look at the -3 on adoption of SRE practices, that would be someone who did not select any practices for SRE. About the same as people that select an average amount. It's really where people go all in that they see rapid improvements to reliability, which is really interesting. So what the guidance I would provide here is that if you're going to go into this philosophy, you need to do it all the way, and you need to be patient as well, right? You can't just do a big bang and switch everything over and expect instant returns. You need to be methodological about how you adopt this philosophy. Okay, and then finally, technical capabilities. We've looked at all 4 of these capabilities across the years, and we find that technical capabilities improve performance, especially with great culture teams. So version control, 33% more likely to improve organizational performance, continuous integration, continuous delivery, and loosely coupled architecture, all 39, 46, and 40% respectively more likely to improve their performance. So let's dig into supply chain security. This was our big deep dive of this year. We're seeing a lot of records exposed, a lot of vulnerabilities detected, a lot of security breaches out in the industry right now. And so we felt let's dig into this. Let's try and provide some data that helps teams. So we did this deep dive into security, and what we found, adoption has already begun, but it's not across the board, right? There's still practices that people need to build into their supply chain. Healthier cultures have a head start. Creating a blameless culture that's psychologically safe really helps teams establish these practices. And there's a key integration point. What we found is that teams that leverage integration are the most successful at this so far. And then finally, it has some unexpected benefits. For example, reduced burnout. So the teams with these security practices are less burned out. Well, just taking a glimpse at the capabilities that have been adopted for supply chain security. The number one, centralized CI/CD. Really not that surprising, because that's been a practice across the board even before we started focusing so heavily on supply chain security. And the least established is signing build metadata to prevent and detect tampering. And so that's an area of improvement. One thing to keep in mind about this graph is that the people that selected centralized CI/CD didn't necessarily select metadata signed, right? There's only a one-way proportion described here, and really across the board, it's very few teams that have adopted all of these. Something to keep in mind. We have a lot of improvement to make sure that we have broad adoption across the supply chain. Okay, I'm going to go through quickly the makeup of the sample, and then I'm going to thank you, and then I'm going to pass to Shamim. So who took the survey? We've been doing this for 8 years. There are 8 different reports. We've talked to now 33,000 survey respondents. That's the makeup of all 8 years. This year only looked at 1,357 respondents, which was an increase about 12% from last year. So I think if any of you on the call took the survey, thank you so much. I also thank all of our sponsors, including Broadcom, for helping get this survey out there to help increase that. So this year we saw 18% were female, 76% male, 1% non-binary, and 6% preferred not to respond in terms of gender makeup. In terms of experience, this was probably the largest difference that we saw in our sample. We had more people with fewer years of experience than in previous years. You'll see in 2021, very heavily weighted on people that had greater than 16 years of experience. This year's distribution had a mean or a median around 6 to 10 years of experience. Our makeup across the globe. One thing I always look for in this data is, are we over-indexing on the US? That's something I always try to make sure that we're not doing. And you'll see that we're doing okay there. We've got 29% represented from the United States. There is a large engineering population in the US. It's not the majority though. We have to look at the rest of the globe. We have to look at EMEA and APAC. And you'll see that we've got a nice sample across the globe, but we still have areas that we could improve. And so we're always looking at this and trying to get a better sample across the globe. And we're looking at things like internationalization, like offering this in languages. So we're making progress there. As usual, technology is the industry that we sample the most. This is the makeup of most of these kinds of surveys, followed by financial services and retail. For company size, we have a nice balance of small and very large organizations that took this survey. For roles, you'll see that most of the people that take the survey are in development, DevOps, IT ops, or our managers. And then for team size, the typical team size is around 8 people or fewer. And the large majority of our respondents also are deploying to containers. And then I'll close here. So thank you all for listening. We continue to see that technical capabilities build on each other to create better performance. We looked at things like cloud, reliability, positive work culture, software supply chain, and drivers of organizational performance. And for the first time, we studied how different capabilities combine together to see the best benefits. So thank you, everyone who took the survey. Thank you, everyone who contributed, and thanks for listening. If you want to continue the discussion, you can join DORA.community and talk to the authors of the report, talk to the contributors of the report, talk to the DORA team, be a part of the DORA team. And so this is a great way to get involved if you're at all interested. We're trying to be more inclusive in terms of how we work on this big topic. So next, I'm going to pass to Shamim. Thanks all.
Thank you, Dustin. Let me try to share my screen here. Can you guys see my screen? Okay, all right. So hello, everybody, and thanks for joining us. Quick intro, Shamim Ahmed. I'm the CTO for our DevOps solutions here at Broadcom. I also serve as an advisor to many of our strategic customers. Have been doing this for at least 10 years now. Background in mostly application development and, of course, DevOps. So really exciting session for us today. Before I begin, I'd like to mention that the Broadcom is the first winner of Google Cloud's DevOps Award for Excellence in DevOps Implementation using the GCP, of course. So a lot of the principles that Dustin talked about in the DORA report have been implemented in our implementation of DevOps. Our journey with Google Cloud started back in 2019, when we started to move from AWS to GCP. We focused a great deal on modern cloud native architectures, modernization of our applications with containerization and Kubernetes-based orchestration, kind of like what Dustin mentioned, all of which are mentioned in the DORA report as key drivers of performance. We migrated since then more than 80 applications to GCP. From a DORA perspective, our metrics include more than 6,500 deploys per day, across 80 apps, across multiple environments over more than 27 Google regions, and many of our applications have very, very low change failure rate, which has obviously been a big driver for driving our customer experience. So, with that, there's a report that Google has published that contains the details of our accomplishments in the space with GCP. I provided the link here. The link is also provided in the resource section, so you can take a look at it offline. There are a whole bunch of other resources that we provide a link to that you can take a look at offline, because we've got a lot of content we need to cover here already. So in addition to having a very mature DevOps implementation internally for our own software development, Broadcom is also a market-leading provider of DevOps solutions that's used by hundreds of enterprise customers worldwide. Over the next 30 minutes or so, I'll provide Broadcom's perspective on the new DORA report, as well as discuss how some of our solutions address the key DORA findings from this year. So let's first talk about the DORA findings that Dustin covered. I'll do a quick recap relative to those that are pertinent to Broadcom solutions. The first one is that we see a sharp jump in the change failure rate, or CFR, for low maturity organizations. Last year, for low maturity organizations, this was in the range of 15 to 30%. Now it has jumped from 46 to 60%. Also, last year, we saw that about 74% of all organizations had change failure rate greater than 15%. This year, that number has jumped to 88%. So that means that as enterprises attempt higher velocity, they end up slipping on quality. In other words, they're not able to balance quality with velocity, right? And that's not a winning proposition, as Dustin mentioned. In fact, the report clearly mentions that simply delivering fast without quality just leads to poor customer experience, right, and doesn't deliver value. There are some customers that we've spoken to, especially in the financial services industry, that have managed to accomplish low CFR, but at a significant overhead in terms of the time and the energy it takes to manage change approvals. For example, one specific customer told us that for every change, they take 3 days of approval time with at least 7 approvers, which in turn, of course, affect their lead time for change, right? So even if they've got low CFR, they've increased the lead time for change as a trade-off. The second thing is that the cloud reliability and culture are interrelated, and together support continuous improvement. I think that's another point that Dustin made. So the report increasingly cites the use of site reliability engineering as a way to drive both the culture and reliability. And we use that extensively within Broadcom, the site reliability engineering principles, and many of our solutions we'll see in just a minute reflect the aggressive use of SRE principles. CI/CD and loosely coupled architectures continue to be technical practices, and they're also strongly correlated with cloud adoption. So obviously, the adoption of the cloud makes it easier to do CI/CD, particularly from a perspective of managing environments, provisioning environments, deploying, and which are key aspects of the CI/CD work. And last but not the least, we saw a lot of emphasis on the supply chain security. There's been a lot of emphasis in the past years around things like source code scanning and pen testing and so on and so forth, right? But now we're saying we're going to look at the governance of the security across the entire life cycle. That includes things like, for example, what about the open source components? Did I build security? Did I deploy security? Did I package security? And so on and so forth, right? And being able to provide governance around that. One key thing from our perspective that we see is the risk around exposure to personally identifiable data, or PII data. So many customers, they simply download data from production for test data management and end up leaking PII information intentionally or unintentionally. Okay, so why do enterprises struggle balancing velocity with quality? And there are many reasons, and that have been indicated in this DORA report and other surveys that have indicated over and over again that quality and testing are the biggest bottlenecks in the DevOps pipeline. And again, there are very reasons for that. So number one is many customers have unoptimized testing, right? They either over test or under test. The test pyramid is kind of wacky, often inverted in the form of the ice cone shape as opposed to the pyramid. And one thing that strikes us from a DevOps perspective is how little insight the testers and the QA folks get from production, even though quality is perceived by users in production environments, right? The ops folks are typically very reluctant to share this operations data with developers and testers, and the data is typically very voluminous and difficult to consume for these kind of personas. Secondly, we see that enterprises struggle with proper test environment setup. With the use of the cloud, it really helps us provision the environment fast, but that doesn't mean that the environment is set up correctly with the right application assets, right? So many times the deployments are erroneous or broken due to configuration definition or change issues. And in fact, using hybrid cloud across multiple distributed cloud environments make this problem even more severe, since we now have to manage deployments across a broad spectrum of environments compared to those in private data centers. Matter of fact, there was a question in the chat that asked about, how do we manage, complexer environments that also include legacy systems, mainframes, Windows systems, et cetera, et cetera. We'll get to that in just a minute. But that's really part of the whole hybrid cloud mix, right? We've got a variety of different environments that we can manage across, right? It's not just a simple microservices pipeline. And that brings us to the issue of test asset management. So test assets include things like test scripts, test configuration, test data, virtual services, and all of these things change very rapidly in the face of rapid code changes, and it becomes very, very difficult for testers to keep pace. Particularly, we have many pipelines, hundreds of microservices pipelines that are across multiple clouds, right? We also see the risk, as I mentioned, of PII data exposure by not masking the data, sensitive data where it should have been masked. And last but not the least, many enterprises are unable to truly predict change failure rate. In fact, more than 70% of the customers that we've surveyed says they're not confident about the release, and many of them actually release and pray, right? Not a good strategy. So now let's take a look at how these challenges map in the context of a typical DevOps lifecycle, right? The two metrics that we see as key business drivers are related to velocity and quality are lead time for change and the change failure rate, right? We just looked at the reasons impacting both. For example, for lead time for change, we typically see enterprises do a lot of their test definition work in the CD part of the lifecycle. For example, they're creating their test or the test scripts or the test data in the CD part of the lifecycle, which means that the pipeline is getting slowed down, right? Similarly, for unoptimized testing, we see test asset management challenges and the inability to predict risk that causes high change failure rate, or CFR. So in order to meet our DORA goals, we need to make some changes, right? First and foremost, we need to make sure that we shift left into the CI part of the life cycle, all the quality ingestion work. And that includes things like, definition of your tests, your test configuration, all your test automation, definition of test data, virtual services, all of that needs to happen in the CI part of the life cycle, right? That's really where quality injection happens. And in the CD part of the life cycle, we need to focus on impedance reduction and then minimize as much work as possible. For example, minimize the amount of testing in compliance with the test pyramid, and also automate as much toil as we can, because any kind of manual work that we're doing there or any kind of wait simply adds to the lead time for change. We also need to automate most of the provisioning and deployment and other toil activities in the CD process, and really cloud services really help greatly with that. Okay. So let's quickly talk about our approach relative to each of the findings. Number one, for the change failure rate, our approach is to help our customers balance quality with velocity, right? As you mentioned, velocity with quality doesn't provide a lot of value. We're also very focused on helping our customers do CFR prediction. This is one of the most exciting solutions that we are building out. I'll be talking about this in just a minute. On loosely coupled architectures, as I mentioned, our approach has been, and what we recommend to our customers, is to re-architect our applications using microservices architecture or wrap them using APIs. All of the solutions that we have support this paradigm from a perspective of design, development, testing, deployment, and monitoring and observability of microservices-based applications, right? We already talked about cloud adoption being key. And I think, like somebody pointed out, one of the key things we're going to keep in mind is that our enterprise customers don't just have applications built using cloud-native architectures, right? They've got all kinds of workloads ranging from mainframes to microservices, ERPs, and everything in between, right? So our solutions help our enterprise customers do what we call full stack DevOps across all these hybrid architectures, right? From legacy to modern. And last but not the least, the CI/CD approach. In order to promote this concept of CI/CD beyond just doing CI/CD, we promote this notion of what we call continuous everything. For all of our process to be truly continuous, every process and every tool in the CI/CD lifecycle must also operate in a continuous manner. We've identified about 8 key practices that we need to implement to make everything continuous, right? We don't have the time to get into that, but I have a webinar that I did recently, and I provided the link for that in the resources. You can take a look at that offline, where we talk about what does it take to make everything continuous, to achieve the continuous everything mindset. So let me quickly go through all of the DevOps solutions that we have. I'm not going to be able to cover all the solutions. We have so many. But let me look at some of them mapped to where they're primarily used in the DevOps lifecycle. So first and foremost, we've got a Rally tool, which is our enterprise agile management tool, where we capture our backlogs, right? Agile Requirements Designer is our model-based testing tool for doing automated test design, and behavior-driven development, visual behavior-driven development and test automation. Layer 7 is our API management tool that allows us to do what we call continuous API management around definition, security, management, and all of the gateway functions. Service virtualization is our endpoint emulation tool for virtualizing dependencies between application components. And I'll go through each of these technologies in just a minute. Test data management is our automated test data and provisioning tool. And it's also a vital tool for masking sensitive data, so you don't have PII issues and also compliance issues like GDPR. Nolio is our automated model-based deployment tool that allows to deploy across multiple environments. Continuous Delivery Director is a release orchestration and governance tool that allows us to do a lot of the metrics and dashboards across multiple pipelines. Our AI ops solutions address the full stack monitoring and observability capabilities. And we also have a whole bunch of tools specifically for the mainframe environment that I'm not showing here. You will find information about those mainframe tools and all and many other tools that we have on the Broadcom website. I just don't have the time to go through all of these things, but you will see that all of these solutions help our customers do this optimization between time to value by balancing velocity with quality. So let's look at these things, each of these tools, in just a minute, so I can give you a little bit of idea on what these tools do and how they help to accomplish the balance. So Rally is an enterprise ALM solution that fully supports all of the needs of enterprise agility, at scale. For example, the SAFe framework and others. So from a perspective of DevOps, it supports backlog management at various levels of abstraction, as well as all the agile software planning, development, execution processes, and serves as a platform for multi-personal collaboration, like the developers and the testers and the product owners and product managers and release engineers and so on and so forth. It provides a forum for collaboration, which is so key to DevOps, like Dustin mentioned. It also provides the ability to provide advanced data integration and dashboards and some analytics capabilities that I'm very excited to talk about in just a minute, where we talk about how to do change failure prediction. So from a velocity perspective, obviously Rally supports all aspects of lifecycle agility, right, including better capacity planning and batch size control, which is key for CI/CD. And then from a quality perspective, Rally supports obviously defect and test management, risk dashboards associated with work items, and most importantly, the new feature around failure risk prediction. So hang on for just a minute before I get to that. I'll cover other tools. Agile Requirements Designer is our model-based testing tool. Essentially, what we're doing here is capturing the behavior of the application in a visio-type diagram, something that we call visual behavioral modeling. For those of you that are familiar with BDD or behavior-driven development, essentially it's visual BDD. So once you've captured the model, we can then use the model to sync back with requirements that are in Rally or Jira or whatever the requirements management tool you have. But most importantly, we can completely automate the test design process and the test generation process, and also most importantly, generate tests with very precise level of test coverage and optimization. So there are various graph theoretic optimization techniques that are built into the tool that allow us to say, okay, here's what I want to do in terms of my coverage. I want the maximum, for example, coverage, or the optimum coverage, or minimum coverage, whatever it is, depending on what type of test you're running. So from a velocity perspective, obviously ARD supports very lean testing, because we can precisely control the amount of testing we do using mathematical algorithms, right? So we can achieve the maximum coverage with the minimum amount of testing. It also automates the test generation process, right? So as your requirements or code changes, we can completely automate the generation of all the tests, so help the testers keep up with the developers. And of course, it also supports BDD. From a quality perspective, it allows us to do better requirements, right? Because without ambiguities, because it allows us to have better collaboration between the product owner, the developer, and the tester in the process of defining those requirements. It also helps us reduce the testing through optimization, particularly in the CD part of the life cycle, where we know we want to minimize the amount of testing, right? So that we can focus our testing based on changes. We've got the change impact analysis built into ARD as well. So it'll tell us exactly what tests have been impacted by the changes we're making. It also helps us synthetically generate the test data and the virtual services that we talked about. And I'm going to talk about in the next slide. Service virtualization is our industry-leading and best-selling product for application endpoint simulation, right? In an age of distributed components, you have all been in the situation, right? We've got dependencies between components, and that gets in the way of being able to test a component that is changing. So for example, if you've got this component that is changing, you've got a dependency on these other things, and it's very difficult to set up a test environment for all these other dependent things to be able to test your app under test. So what service virtualization does is it helps you get around this by creating these lightweight simulators that stand in for these endpoints, right? And it behaves exactly like this endpoint. So which means that it's really now easy to create these endpoints and set them up and provision them into your environments, and really truly promotes not only agile environments, but also agile development and testing. Matter of fact, I would contend that it's not possible to do agile development without SV. So from a velocity perspective, SV allows us to do faster development, obviously, and better and faster test environments. by removing all these constraints. It also allows to do faster and agile deployments because our virtual services can be lightweight compared to, for example, a real application like a mainframe or an SAP ERP. They can be packaged into containers and can be easily integrated with CI/CD frameworks for automated deployments. From a quality perspective, as we obviously supports the shift left, right? Being able to test early at the component and the unit level, and an important subset of this is being able to do early performance testing. One of the reasons why we see customers don't do a lot of early performance testing is because it's very difficult to set up performance environments. Whereas SV can not only simulate the endpoint, can also simulate the performance of the endpoint, which means that we can completely simulate a complete performance testing environment, an auto-scaling environment, matter of fact, in a matter of minutes. So SV can also be used to do shift right of testing, for example, doing chaos testing and destructive testing, which is very important for addressing reliability issues, like Dustin mentioned. Okay, test data management is our industry-leading test data automation tool. It helps our customers do synthetic data generation as well as do subsetting and masking of data from production. Most importantly, identification of sensitive data and masking of the data. Right, very very important to address the PII issues. So from a velocity perspective, TDM allows us to do obviously faster test data management because test data management takes time, effort, and one of the biggest bottlenecks, honestly, in the CD pipeline, right? If you talk to our customers, it takes a lot of time and energy to create and provision the data. TDM really, really helps with all of that. And from a quality perspective, it allows us to do better test coverage and then also negative testing by provisioning negative data, edge case data, et cetera, et cetera. And of course, we talked about the PII data protection, sensitive data protection as well. Nolio, our model-based automation tool. The key thing about Nolio is that it's a full stack deployment tool, right? It's not just about deploying microservices, right? We are able to, using Nolio, deploy across the full stack that goes everything from microservices to mobile and of course mainframe and other complex things. The more complexity Nolio, Nolio is really built for complexity, right? It's really built for very very complex deployments across multiple type of application stacks across multiple clouds. And the whole principle it operates on is that it's model based. You model once and you deploy everywhere. So from a velocity perspective, obviously Nolio allows us to do not only faster deployments but also more accurate error-free deployments, right? And makes it easier to maintain the complex deployment pipelines, right, in the form of a model-based representation. And from a quality perspective, Nolio allows us to do secure and error-free deployments as well as support shift right of testing by supporting things like AB and canary deployments. Continuous Delivery Director is our release orchestration tool. I'm going to speed up a little bit here. Among the many things that it does is it provides us a risk score for all the applications that it monitors, right, along the CI/CD pipeline, and it does this using looking at data like your test coverage, your code complexity, and so on and so forth. So it provides a proactive risk score before going live, right? So, and that's a very important perspective from a quality perspective. It also allows us to do what we call code change impact testing. Every time developers check in code into the source code management system, CDD captures it and tells the developer, here are the set of tests that have been impacted by the change that you absolutely need to focus on. And of course, from a velocity perspective, really helps us automate all of the process execution. Also automates the data collection from multiple tools that are tied to all these processes. If you can imagine, in a CI/CD framework, you've got at least 10 or 15 different tools, and collecting the data from all those tools and creating reports and dashboards is a very, very onerous task. It also provides support for faster audits because it provides automated audit reports for customers that need audit support. And last but not the least, our AI Ops solution is all about comprehensible full stack observability, across all types of environments, both production and non-production. It does infrastructure, digital experience, network, and mainframe monitoring. Again, the key things here are being able to do faster MTTR because it provides proactive guidance around things that are failing or about to fail, and clearly automates the toil around healing because we can automate the remediation workflows, and then provides automated insights using all of this data that we collect in production using AI Ops technologies. So from a quality perspective, it supports proactive remediation. It alerts us about failures that are impending so that you don't actually fail, and therefore reduces Sev1 outages. And of course, all of this helps to improve customer experience. Okay, now for the most exciting feature that I'm going to talk about, I'm going to show you this disclaimer because this is a feature still under development. This legally is all that it means that, hey, we haven't announced it yet. We're not committing to anything. It will be announced hopefully the next quarter. So this is our a new feature we're introducing. We're calling deploy with confidence, and essentially it's a observability solution that we've shifted left to the CI/CD part of the lifecycle that allows us to do machine learning based risk prediction based on past failure data. So what we're doing essentially is collecting data, for past failures, correlating that failure data with pre-production data from the CI/CD perspective, using that correlation to create machine learning models. Then we apply the machine learning model to the current release or current deployment that allows us to predict what is the risk of failure of this particular deployment or release for every change that we're making, right? So in Rally, for those of you guys that are familiar with Rally, this is our agile management tool. You see here all the backlog items and everything. So we're introducing this new column here called the deployment confidence score, which is a inverse of the risk score, and it tells you what the confidence score is, right? But most importantly, what it tells you is also the factors behind the score. For example, it could be because of large code churn, or it could be because of insufficient test coverage. So this is key for driving continuous improvement, like Dustin was talking about, data-driven continuous improvement, because now a developer can look at this thing for every commit he or she is doing and say, hey, I have all these unaddressed issues that are likely to cause failures. Let me go quickly fix it. And the moment they do a commit again, with these fixes, the risk score will be updated, right? So, and this happens continuously, and that's what we call continuous failure risk prediction. So it starts with, with requirements, right? Many of our customers tell us our requirements are crap. So starting with the requirements or user stories, right? We will analyze those and we'll say, hey, how good are your user stories? I mean, for example, they're not structured properly, or they don't have good acceptance criteria, or if it acceptance criteria missing, right? So we'll look at that, and then it continues through the life cycle. For example, as I mentioned, for every code commit the developer will do, we will collect data from the source code management system, the code scanning system, et cetera, give them feedback right away. Here's the risk score for this change you just made. Go better fix it, right? And then of course, as it progresses along the life cycle, so for example, when you do a build that has multiple changes from multiple developers, will create a score for the build, and then as you go along the life cycle for the component level, for the system level, and then for the release level. So as you can see, this is very, very useful for multiple different personas, and drives what we call data-driven collaboration across personas, which, as we talked about, is very, very key. From a DevOps success perspective, is to build that level of collaboration, provide this early insight, provide the platform for proactive understanding of the risk, and most importantly, continuous improvement, because it helps us really understand what's causing the risk, and then address those things. And of course, once it has gone to production, we collect the failure data from production. We feed that failure data back into our model, and the model keeps learning and getting better and better. Now, obviously, I don't have much time to explain all of this in detail, but we've got a blog that I wrote on what I call continuous observability. This is a link that we provided on the resource site. Can take a look at that, and you can understand the details behind this whole process that we just talked about. So this new approach gives us a new quantitative approach to regulate velocity based on risks. So Dustin talked a lot about site reliability engineering. So for those of you that are familiar with SREs, they use this the notion of error budget consumption to control regulate velocity, right? So the more error budget is consumed, they throttle velocity with the remediation engineering and more technical debt management. The lower the error budget consumption, they allow more velocity, right? So now that's the SRE approach, right? So this new approach that we just talked about around risk prediction gives us the ability to combine both the approaches, right? So for example, developers and testers can now look at the risk score and say, hey, my risk score is low, and therefore I can promote more velocity. If my risk score is higher, I need to do more hardening work, right? So now if I combine the SRE approach and the dev test approach, right, it gives us a platform for broader collaboration and true data-driven collaboration between all these different personas to look at it from the perspective of how is it going to affect my risk of deployment? What is the SRE view? What is the dev test view, right? How can I use all this data? And again, we talked about how difficult it is for the dev and testers to get data from production and use it meaningfully, right? So this mechanism provides us to not only get data from production, also collect data from pre-production, but more importantly, correlate the post-production and pre-production data to get machine learning-based insights, all automated, all real time, right? So again, I did a webinar on this thing called Balancing Velocity with Quality that you can take a look at, that describes this whole approach around how we use this approach. So again, all of this, you can take a look at it offline. So We want to go beyond DORA metric. That's our vision to support what we call DORA, DevOps intelligence. So if you look at the DORA metrics as it is now, they are what we call descriptive metrics. That is, it measures what is happening now, right? Our deployment with confidence solution provides additional insights into what we call diagnostic analytics, right? Why is it happening? Why is the risk score so high? Why is it likely to fail, right? It also provides guidance around predictive, right? So in other words, what will happen in the future? I mean, what is the likelihood of this thing failing? So it'll answer, for example, questions around, what's causing the high CFR, what's the CFR of the next change, or how will changing something like the test coverage impact my CFR? It will tell you, precisely what the impact is going to be before you actually do it, right? Because you could do the what if analysis on the different factors, right? And our goal is obviously to get to what we call prescriptive guidance, which is what do I need to do? Matter of fact, one of my customers, when he looked at this presentation, said, "Hey, can you analyze all my data and just tell me what I need to do?" Well, we're not quite there yet, but we're getting there, right? So we will eventually get to a point where we can start to do prescriptive analytics. But before that, we have to get to the predictive first. But in the meantime, how can we help our customers, with the DORA metrics and maturity? We do a lot of DevOps discovery workshops where we go in there and understand what their life cycle is, what their constraints and bottlenecks are. We do value stream mapping and we make improvement recommendations. And then we do detailed solution design workshops where we provide blueprints for goal-driven improvements. And we also look at, for example, what data they have in all of their tools. And whether that data is suitable for consumption within our deployment confidence, obviously, because the machine learning system, we want data to be clean. We want at least about 6 to 1 year's worth of past release history to be able for this to work. So we will do all that analysis to see if this will work. We also do a lot of best practices workshops, aligned with DORA and many of the other best practices that we obviously have learned and adopt ourselves in our own software development organization that helps our customers improve the maturity. And last but not the least, we like to continuously promote this notion of continuous improvement and learning. We put out all these capabilities and blogs and webinars and white papers and everything that we encourage our customers to look at and learn and continuously improve. So with that, I'm going to bring it to a close. We've got about 3 minutes to open it up for any questions. Cody, over to you.
All right, let's jump right into it. So how does service virtualization speed up test environment setup?
Great question. So as I mentioned, service virtualization is a great way to emulate an endpoint, right? So think about if your application has a dependency on a mainframe system or a complex ERP like an SAP. Think about the amount of time it takes to set up a test environment for SAP, for example. It takes you hours, right? Not just hours. It's also very complex and cumbersome. So with SV, you can replace the SAP system with a simple emulator that looks and feels like SAP. Right, it's a few kbs, in size. You can package it as a container and you can deploy it very quickly. So when you're setting up an environment in the cloud, you can provision the environment very fast. You can complement that speed of provisioning by deploying something that looks and feels like an SAP but takes only a couple of seconds to deploy. So there you go. That's the answer to the velocity question around environment provisioning.
Right. Are there risk score goals or minimums?
So there are two different ways of looking at this. One is the more of the heuristic approach, right, which is one of our tools. We talked about CDD that supports, where we look at the traditional approach to what is good, right? For example, it says you need to have about X percentage of code coverage, or Y percentage of test coverage, et cetera, et cetera. And we let those goals be defined by you, the customer or the user, okay? So in many sense, it comes to the default set of good goals, but we would like you to be able to say what is good for you, right? Because every application, every customer is different. Now, the machine learning system, on the other hand, is based on real data, failure data, right? It actually correlates failure in production with pre-production data, right? So it determines what is good based on the correlation. Obviously, we will test for how good the correlation is, but this is really based on good is as perceived by the user, right? It's as good as how many SEV1, SEV2 defects you have in production, right? How many failures, how many CX incidents did you have? So that is truly what is good, because good is perceived by the user, not what we by which we're not defined. So we let the machine learning define what good is. But again, there are ways to override all of that. Good question.
All right. Well, Dustin and Shamim, that is all the time that we have today. So I do want to thank both of you for joining me today. And I would like to also give each of you an opportunity to give our audience any parting words before we do close out and go off the air.
Dustin?
Yeah, sure. Well, yeah, thank you everyone for attending. Culture matters a great deal, and psychological safety matters a great deal, as well as technical practices and delivery performance and organizational performance. So focus on the team and you'll see the benefits. What about you, Shamim?
Yeah, thank you. I completely agree. I mean, DevOps isn't just about tools, even though we are a technology company. It's very, very important that that we use all the right cultural practices that are identified in the DORA report and encourage collaboration, right? I mean, collaboration is a big part of the culture. So our point of view is that we want to encourage data-driven collaboration, right? We've got so many tools in the pipeline. It's very, very difficult. So many different personas, right? Everybody looking at their own silos, and it's very difficult to collaborate using data-driven, insights if you have all these information silos. So our approach is, hey, let's try to build something where we can, integrate data from multiple different sources. Everybody has a common point of view of the world, so they can actually have a conversation, right? So it's not like I'm saying this, you're saying that, but let the data drive the collaboration, let the data drive the culture, right? One of the key things, for example, the DORA report mentions is the way to drive culture change is to focus on the technical practices, which is kind of weird, right? Using technical practices like CI/CD improves culture because the moment you enforce those technical practices, you'll see the mind shift in how people work. And we're saying here, let the data also drive along with the practices.
Wonderful. Well, thank you both so much for taking the time to join us today and providing all of this insight. I did promise we'd be giving away 4 $25 Amazon gift cards. So our winners are Kelly S., Santosh K., Vladimir K., and Janice V. So to our 4 winners, congratulations. Look out for an email to claim that gift card. But if you don't happen to see that email, please keep an eye on your spam folder. And I'll also remind everyone that this session was recorded. You'll receive an email with a link to access the recording on demand, or you can find it on the DevOps website at devops.com/webinars, and just be sure to look in the on-demand section. I'd like to thank Broadcom Software for sponsoring today's program, and to everyone who joined us today for the past 60 minutes, thank you so much for being here. We do really respect your time, and we do just want to ask for one more moment as soon as we close out, a survey will pop up on your screen, and we'd really like your participation there. Otherwise, we do hope to see everyone at an upcoming Techstrong Learning program. Have a great rest of your day, and Dustin, Shamim, thank you so much once more.
Thank you. Bye-bye.